建筑会公开课的直播间，我是主持人丽丽。相信关注我们建筑会公开课的老用户朋友们啊，对今天的嘉宾应该不会陌生。在去年11月的时候呢 ，Resene Construction 的 Mike 就为我们讲解了防火墙系统的许多知识。本期公开课依然是来自于 Resene Construction 公司的总经理 Mike Oates。Hi Mike, thank you for coming and bring something exciting and the system to share with us.
Yeah, certainly have.
Awesome. 那么本期公开课的重点呢是关于建筑规范，也就是 Building Code 在 H1 章节那个Emergency Energy Efficiency 能源效能方面的这个更新啊，以及在这个新规下外墙系统又如何为您去排忧解难。相信很多朋友应该都了解保温棉，或者说是通过加厚窗户这样的方式，因为这些是建筑内部的保温措施。那么外墙的保温可能对很多人来讲就没有那么熟悉了。在今天的直播中，如果您想了解 Resene Construction 外墙系统如何为您的爱家或项目起到保温隔热防潮的作用，那就请一定要认真学习本期知识。老样讲，我们本期公开课依然是有奖抢答的环节。今天的问题是，请问 Thermal Gold 100 ml 的厚度的 R 值是多少啊？如果您认真观看公开课的话，那么答案您是一定会知道的。Okay, Mike, you may start to share your screen as you wish.
Thank you.
That's all good. OK, 如果您现在刚刚进入到直播间，然后可以通过点击屏幕来切换屏幕的大小，然后以及如果您是用电脑观看的话，记得点击这个屏幕上方的 Film 的这个水印来调整这个屏幕的配饰。OK, yeah, Mike.
Thank you. Welcome everyone to the presentation this afternoon. I picked up a few words from Lily's introduction there. Our discussion today is around outsulation, and that's about warmer, drier, and healthier homes. Now, the discussion today, I start talking about the building code changes that are happening in terms of energy efficiency in New Zealand, and I will be then talking to external cladding solutions that are available to provide added thermal performance to residential construction builds, and also talking about one of those little forgotten parts of the building, and that's the foundations and the importance of those to be thermally insulated. A lot of external cladding, in particular insulated exterior cladding systems, protect the structure and those living inside throughout the year. So keeping the heat out during the summer and the cold out during the winter. So insulation is not just for the winter to keep the warmth in. You know, everyone really likes to think about insulation as keeping things warm, but equally in the summer, we want to keep the heat out so that we can keep the cool in. So you're not running your air conditioning units for hours just to try and keep a comfortable indoor environment. Mm-hmm. So insulation, in a nutshell, insulation helps keep cold things from warming up and warm things from cooling down. All right. So think about your eskies when you want some cold drinks. You put the ice in there, and air is the insulator by and large. So air is one of the best insulators for thermal protection, and it works the opposite with if you want to have a hot drink. You have I know if you have a Bodrum coffee cup, a glass Bodrum cup, they're double-walled cups, and you've got a gap of air between the hot liquid and where your hand holds onto it. It does two things. It stops your hand getting burnt, but it also keeps your drink warmer for longer. So thermal performance is really important. So once again, high thermal performance not only increases energy efficiency in buildings, but improves the health, comfort, and well-being of the occupants. And those are the key takeouts of why the building code is looking to change. Now, you have a lot of information over the years, particularly through the media, about, and you generally see it in the winter, where houses are cold and there's water running down the windows, and generally on the inside of the building, these are old buildings, and the insulation is certainly significantly better as we build today, but it's being improved yet again to get us further up the international food chain in terms of building performance. So back in November last year, the 5th edition of H1, which is the energy efficiency section of the building code, and you'll see up here, and Lily did ask me before, what is AS? And AS is acceptable solution. All right. So if you see something that's got an AS beside it in terms of a building code, that means it's deemed to comply with the building code. So if you follow these releases and information releases from the government, and they state it's H1, AS1, that means it's an acceptable solution and is deemed to comply with the New Zealand Building Code. So this was released in November 2021 and effective from the 3rd of November 2022, and that will need to be used for all consent applications. I did have a couple of comments because recently, as 2 days ago on the radio, there is a little bit of discussion about whether it will be implemented on the 3rd of November. And I think that's just more of a timing thing. These changes have been pretty thoroughly thought out for the last sort of 2 to 3 years. And it was about, can these changes be implemented accurately and timely? The majority of these implementations could be achieved within 12 months. But I think what's happened is because of some of the supply constraints in the market, international shipping, and all these sorts of things, they've added a few more layers to timing. So you may see a change of that implementation date from the 3rd of November. It may get pushed out. But I have to go with the information that I know at the moment. So we'll work on that.
Cool. Sorry, Mike, just go back to that one slide. When you talk about from the 3rd of November 2022, which will be in a couple of months, wow, surprisingly, does it mean is all the new building consent application, when they try to write something for their coming projects, it have to make the H1 standard?
Yes.
Cool. 在这里跟我们的用户朋友们解释一下啊，这个我们新的 H1 的这个标准是从11月3号所有的递交的 building consent 的这个申请开始实行的。Yeah. Okay. Sorry, Mike.
Yeah. So and that's important because if you're designing projects now and they get consented before that date, they still comply to the old regulations.
Yeah.
But this is about being proactive and having a look at what this new solution looks like so you can get your clients ahead of the game.
Yeah.
All right? In terms of what the requirements will be in the future. Because I'm sure if someone's building a house and they're building it on the 4th of November, they would like to think that it is compliant with the current building code. You know?
Yeah. And also, I think in the future, when the property is on the market, it will be more competitive if at the time the requirement is being met, even though like the building consent was before the 3rd of November. So I think you're right. We need to think ahead and being very proactive. Yeah.
Yeah, very much so. So thermal change. So energy efficiency for housing and small buildings is what MB and the change to H1 is about. So just to clarify, MB is proceeding with changes critically to the roof, window, wall, and underfloor insulation requirements. And they've issued the new acceptable solution, as I just showed you, and the verification method. Now, the verification method is we mentioned just before the acceptable solution, there are what we call in the building code alternative solutions. Now, if you have an alternative solution rather than an acceptable solution, the proof of your systems complying with the building code is by using what they call a VM or a verification method. All right. We've had these for years in New Zealand, and it's one of the key pathways for product suppliers to prove that they do comply with the New Zealand Building Code. So the verification method, and sometimes you might get VM2, VM3. They've just updated the versions of those verification methods. All right. So these are applicable for housing and small buildings. The new insulation requirements that I'll be discussing aim to reduce the energy needed for heating a residential home of approximately 40% over minimum requirements. So you're going to get up to a 40% improvement on the thermal performance. One of the key things that we look at here, and that is one of the key changes that MB looked at when they made these changes to energy efficiency was the climatic zones of New Zealand. Now, New Zealand's a bit of a strange beast in that we are longitudinal, all right? So we go from very, very warm in the northern climate, in the northern parts of New Zealand, to almost subantarctic conditions. I was talking with someone this morning who's working in Gore, and they started their day with a frost already.
Where is that?
Where's Gore?
Yeah.
Gore's down here.
Okay. Wow.
All right. So they're already getting frosts, and this was 8 o'clock in the morning when I spoke to him, and he asked me how warm it was in Auckland, and I said 18 degrees. Mm-hmm. So it shows you how significant the temperature range can be in New Zealand. So on the left-hand side here that I'm showing you, that is what it currently looks like. We have 3 climatic zones. You have climate zone 1, which is the top of the North Island. Majority of the North Island is climate zone 2, excluding what we call the Central Plateau. And the Central Plateau is Taupo and around that entire higher section, Ruapehu, all those areas. And then obviously the South Island is climate zone 3, just because it's further south, gets a lot colder. So what they've decided to do is they've changed and they've increased the amount of climatic zones in New Zealand to better represent all the different zones. And we have now got 6 climatic zones. So northern doesn't really change. So for everyone up in the northern region here, status quo. That's even been brought down further down to the Bay of Plenty and out to the Cape prior to Gisborne. You've noted there's a reasonable change here. So we're now climate zone 4 through the Central Plateau. And on the previous map, you can see Central Plateau pretty much was the entire South Island zone. So now we've changed this zone here to climate zone 4. Climate zone 2 is around the west coast of New Zealand and the east coast of the North Island. Sorry, the west coast of the North Island, the east coast of the North Island are climate zone 2. Climate zone 4, central and the lower west coast of the North Island, east coast of the North Island, and the South Island west coast. Climate zone 5 is pretty much North Canterbury, South Canterbury, all the way down to the sort of Oamaru area here. And it's also now including Dunedin, all right, and South Otago. The climate zone 6 is the coldest, which will have the highest performance requirements, and that is Central Otago and Southland.
Yeah.
So quite a significant change.
Sorry, Mike, would you quickly cover Auckland, Hamilton, Christchurch, and Wellington? What zones these cities are in the new climate zone?
Yeah. So this is Auckland. We're sitting in that climate zone 1. Yep. All right. That includes Bay of Plenty down here. Mm-hmm. Then we have Wellington, and that's sitting at climate zone 3.
Yeah.
Christchurch sits at climatic zone 5, and so does Dunedin.
Yeah. Cool.
If you're in Queenstown over here, you're sitting at climatic zone 6. Nelson, you're in climate zone 3, same as Wellington. And if you're in New Plymouth, looking at designing a new Plymouth and building New Plymouth, you're in climatic zone 2.
Cool. Thank you.
Right. So sorry about all the charts, but these are out of the document that is being sent through from in terms of H1 and these requirements. One of the biggest ones, and I'm not going to drill down too deep around roofing and window requirements and everything, but there's a couple of significant moves, and obviously roofing and windows are probably and cladding are the two key ones that I'll be talking about. And I'm not going to say this is what this means in terms of what you should design. Really just have a look at the thermal difference and the ratings that are now being required. So if we look at the roof, doesn't matter what zone you're in, the new insulation requirement is R6.6. So that's a significant lift from current, like nearly double, at least double. So the roof insulation required across the country and the thermal performance of walls are staying pretty status quo. They didn't want to move too much around that space. All right. But looking at the windows, if you're in Auckland, which we noted before being Category 1 and Category 2, you're getting a lift to 0.37R for your window requirements. You're moving into the colder regions here with Wellington, Christchurch, the west coast of the South Island. You're looking at the joinery performance requirements lifting to 0.46. And if you're getting into the South Island, deep into the southern region, you're getting up to R.5. And so they're pretty significant lifts. And I'll talk a little bit more about the window and the transition of that, because the roof is going to be happening straight away. But in year one, windows for the new window insulation requirements will have a two-step approach. So for the warmest part of the country, climate zones 1 and 2, including Auckland, these will be an interim increase by November this year that'll be available. In year 2, climate zone will see additional increases. All right, includes these colder climates as well. All right, that will be transitioning through to November 2023. And I would highly recommend that if you're designing or looking at building in these timeframes, that you talk to your joinery manufacturer about what the transition times are. Is the joinery going to be applicable and suitable? Because there's going to be quite a bit of challenge around that space. For the last couple of years, we've been working with joinery manufacturers about cold points and how we flash and work with joinery detailing. So there's some significant changes there that really need some good eyes over. The other important one is on slab on ground floors and improving the insulation performance of on slab insulation. And I'll talk a little bit about that later on with what we're doing with our insulated foundation systems. So a question before you, did you ask me this question yesterday, Lillian? That was, what's an R value?
Yeah, what is an R value? Resistance?
Yeah. So do you want me to answer that question now because it seems appropriate?
Yes.
So an R value, you see this on your insulation that you get delivered to the project, the in-wall insulation, and it's a measure of how well a layer of insulation or complete wall or ceiling can resist the flow of heat. So it's about how much a particular material can resist thermal loss. All right. So that's the most basic way I can sort of explain it without getting too deep. All right.
Yes. The higher R value is, the better the resistance performance.
The thermal resistance. Yeah.
Yeah.
It resists losing warmth or cool.
Yeah.
All right.
Mm-hmm.
So there's a comment made by MB, and there were concerns raised about the availability of local New Zealand products to meet demand for higher performing insulation. And they especially noted for wall cavities where space for additional layers of insulation is limited. Personally, now this is my personal opinion, I think this is rubbish, and is based historically and very broadly on the presumption that the dominant way to insulate is in-wall insulation. I don't believe this is correct. That is just the most common method that majority of buildings, they have to have in-wall insulation. But it promotes particular insulation products only. Now, when you have I'll just skip to that. So when you look at the wall insulation, status quo, R1.9, so R2, let's just say R2 across the board, there should be a minimum expectation, all right? They're looking at taking us to option 2, which is comparable to international standards. And this is in-wall insulation. This is what this can achieve. Now, they haven't gone to the beyond international standards, i.e. going to try and get an R5 wall. That would mean you're going to have to, as they explain it in ENVI, and they were concerned about it, we've got to make our walls a lot thicker. You're going to have to build with 6x2 framing and all sorts of other potential ways to do it, but that'll be the dominant way. Make the walls thicker so we can fit more in-wall insulation in the cavity. Now, my discussion, as I mentioned at one of the very first slides, is outsulation. And there's no better place for thermal performance than outside the structure. So I'll just skip on to the next one now.
Yep.
This is what, and this is probably the easiest way I can explain how in-wall insulation lacks continuity. So every bit of framing, every nog, every stud, every joist is a thermal break. So you're infilling insulation here, but there's no insulation wherever the timber framing is. All right? And it's interesting. There was a report done by the Beacon Pathway, which is about energy efficiency via brands. And the research indicated that between 24 to 57% of light timber frame walls are comprised of wall framing. All right? And that will have that ultimately ends up reducing the R value and giving you it at an R2 insulation. It'll reduce it down to R1.44, which is well below the minimum building code requirements. Some of the key stuff we look at with this insulation is you look at the amount of timber at lintels above windows and doors, double studding beside windows and doors, internal corners, changes of cladding. There are so many areas that don't have the ability to be insulated.
Mm-hmm.
I'll jump onto my next slide.
Yeah, sorry, just there, I just want to jump in and make a comment. So it feels like, to me, after explaining this page, insulation feels like it's not a whole thing that can prevent the heat loss, because for the log part, no, sorry, the what's the word? The tree, the wood part, the frame.
The timber,
the timber. Yeah, sorry, the timber part is not doing anything to keep the heat inside or outside.
Nope.
But what we're going to introduce today is almost like an envelope that covers the whole project or the whole building. And that's a whole thing. Yeah, sorry, I'm just going to repeat what I said in Chinese. 所以其实我们从就是这一篇这个 PPT 的内容上可以感受到啊，我们这个考虑到内部的这个保温措施，不管是升级双层玻璃也好啊，或者说是通过在墙里面去增加保温棉的这种措施，其实还是会有一些这个湿温或者说是温度是从哪个地方流失的呢？就是我们的那个 framing。这个木头的部分，因为木头本身它是不具备阻隔温度传播这样的一个功能。那么虽然我们还没有讲到后面这个具体的系统，但是其实这个系统它是一个像一个大的信封一样，把整个 project 整个这个项目从外部给它包裹起来了。那么外部就相当于有的时候我们这个保温杯的那一层就是空气。 那么今天我们要聊的这个 system 这个系统，它同样也是有一层类似保温杯中间中空的那个空气的部分来阻隔任何温度上传导的这个流失。Okay, Mike, you can move down to the next slide.
Okay, so improving the thermal performance of walls. As I've just spoken about, firstly, thicker walls. So we talked about you can increase the thickness of the framing to put more insulation in the walls to get better thermal performance. That means more timber and or steel at a much higher cost. All right. And that's a resource that is limited as well and challenged at the moment. You also have the double glazed joinery. You're having to do heat reflective glass, low E coatings. You might be looking at UPVC frames, thermally broken window frames. These things are going to have to happen. We can't change that. But that also equals higher cost. Now, when we look at our outsulation systems, we can do an external thermal envelope, no change to the framing, significantly reduce thermal breaks, and lower costs. So we don't have to make our walls thicker and add more insulation to achieve better performance at an increased cost. All right. What I'm going to be talking about today now are two products we have. One is Xtherm Blue, and they can be fitted. I'll be talking about the different systems and the way they can be fitted. We have a Xtherm Blue and an Xtherm Gold. One of the key things with Xtherm Gold is that it's made right here in New Zealand, so that it is available locally and we don't have any challenges around international logistics. So the systems for outsulation. So excuse my pretty pictures here, but you have to imagine that there is timber framing and building underlay behind these particular images. These are our insulated facade systems. They can be installed over timber or steel frame structures. All right. They're all on a cavity and as you'd normally build under the building code today with any cladding. We also have, using exactly the same substrate, be it the Xtherm Blue or the Xtherm Gold, we actually install them over masonry structures as well. And they're called our masonry overlay systems. And they are direct fixed onto the masonry structure to outsulate the building. All right. So you get total thermal performance for that walling system. Just some quick differences of the products. Our Xtherm Blue is imported. It's not a product there's no manufacturing equipment for this in New Zealand currently. It's a very high density. It's very, very hard. And it has very good thermal performance. Xtherm Gold, on the other hand, was made here in New Zealand. It's a very high density and it has far greater thermal performance even than the blue board.
Sorry, Mike, would you mind go back to 2 slides? I just want to quickly tell people, because I saw people asking like the structure of the system. So just, this one. Sorry, just stop there. I'm just going to explain a bit.
I do show some pretty pictures later on about how it goes together.
Okay, cool. 所以大家可以看到从左到右啊，它的这个层次其实就是我们图片的最左侧，它其实就是大家可以看到的外墙。然后那么图片最右侧呢，这个 batten 它是会直接连接到我们的房子的结构上 framing 上。然后左侧的这两个 system 呢，它是可以和木或者是钢的这个框架来进行连接，然后右边的这个系统它是直接可以做到 concrete 这个 framing 上面去的，然后中间的这个材质不管是蓝色的还是gold， 就是他们叫金色，但是我看上去是黄色的啊，就是这两个非常厚的材质正在发挥他们这个阻隔温度传导这样的一个作用。之后呢，麦克也会讲到我们中间的这个材质它究竟是什么。OK, Mike.Yeah, sorry to interrupt.
Right. Okay, so those are the two substrates or the two base products that we have. The key differences, I mentioned density. So The Xtherm Blue board is 35 kgs a cubic meter. Now, to put that in perspective, standard polystyrene that can be installed externally at the moment in New Zealand as a substrate to plaster over is only 18 kgs. So we're nearly double what standard outsulation boards are in New Zealand at the moment. Then the Xtherm Gold is over double the density or the hardness of standard styrenes here in New Zealand. The Xtherm Blue board, because we import this board, we only bring in 50 millimeter thickness. But the Xtherm Gold that we manufacture here in New Zealand, you have some choices. You can decide to do 50 millimeter, 75 millimeter, or 100 millimeter thicknesses. All right. The sheet sizes, because it's imported for the Xtherm Blue, so we get as much as we possibly can into a container, are 2200 millimeters long by 600 millimeters wide. Here in New Zealand, we can do those 2400 millimeters by 600 or 24 by 1200 sheets. So we can get a lot more product in dimensions. We've got a lot more flexibility. We also do a 1200 by 600 that we use for our masonry overlay, and that's available in both of those products. The two different thermal performances I'm going to show you. So it's important here. So what I'm talking about now in terms of thermal performance for these systems is when it's installed over a cavity on timber or steel framing. All right, so you've built your structure, you're building underlay, then I'm putting this system on top on a 20 millimeter cavity. Now, in terms of when we have an outsulation system on the outside of a structure, there's a requirement for us to derate the insulation or the thermal performance by 0.45. And that's the general consensus for the thermal loss because you've got a cavity, okay? So for this system here, for Xtherm Blue, you'll get R 0.92. And then on top of that, you add your in-wall insulation. So if you're using R 2.2 in-wall insulation, you can add 0.92 to that, and it gets you to just over R3 walling system. Xtherm Gold, on the other hand, if you sat there and did a 50 millimeter Xtherm Gold at a derated R 1.265, added that to your in-wall insulation, you get an R 4.065. So even with our base minimum thickness of Xtherm Gold, you actually achieve the new performance requirements under the building code. If you want to go to the beyond the international standard, if you put 100 millimeter Xtherm Gold on the exterior cladding, and that's at a derated 2.585, add that to your R 2.2, you're over 5. You've got an R5 wall, all right? So you don't have to make the walls thicker and put more insulation inside the house. You can actually do it without insulation, all right? When we go, so that's the cavity-based systems. When we do masonry overlay, or we're fixing the cladding system straight onto a masonry structure, we don't have to worry about thermal reductions. The thermal performance is a direct reflection of the thermal performance of this insulation board, or the outsulation board. So the blue board will give you R 1.65 at 50 millimeters thick, whereas the Xtherm Gold, that'll give you an R 2.43 all the way up to an R 4.87 at 100 millimeters thick. So you can see the thermal performance requirements are pretty significant.
Mm-hmm. Sorry, just to clarify, so the two different situations we're talking about right now is the second one is when it applies with the masonry system. And the first one is, this one and the previous page. So this one is for, stop there.
Over it's over a cavity.
So when we're calculating this, we're actually thinking about the insulation. Yeah, and because there's a cavity, we have to deduct 0.45.
Correct.
Okay.
So what you'll do, this is on our specification brochures that that'll be sent out next week. is when we put a thermal performance number, like an insulation rating on a specific system, we automatically derate it.
Yeah.
So all you need to do, and the clients need to do, is like, right, what is that number? Because I don't want to tell you that the thermal performances are 1.65 and then they have to derate it because it's on a cavity. You know what I mean? I want to give the most accurate information for this particular system. All right? Okay.
And then this one is when it doesn't have a cavity.
When it doesn't, it's direct fixed.
Cool.
All right? And the only time we do direct fix is over masonry. All right?
Yeah.
So looking at the insulated facades, and I wanted to show you a couple of pretty pictures so you understand what it looks like. So in this image here, you have your building. Excuse the branding in the background. I'm not sure, and obviously the building paper, we're not selling that stuff, but you can have a look at, this is the substrate, these are the sheets, this is the cavity battens, and these are the fixings. We fix the substrate through the cavity batten into the structure. All of the panel joints are all foamed as well, so we don't have any thermal breaks around the panel edges. All right. So it's full cavity system. That's obviously our Xtherm blue. The Xtherm gold, and this is a project that was completed a couple of weeks back in Christchurch, and this client went to our 100mm thick Xtherm gold. So they went for the thicker insulation board with a higher thermal performance. Still foaming the sheet joints, still fixing exactly the same way, and then obviously we apply our coating system to that. This gives you an idea before we've finished doing the plaster work. This one's all getting prepared with the corner flashings and flashings around windows and openings, the plastering at the bases. And this image in the bottom right shows the end result. And this is a project down in Central Otago. And if you can see in the background here, that's Lake Dunstan. So it's pretty cold down that way. So this was one of our outsulation on a cavity.
Yeah, sorry, just someone, I saw Tony ask a question. He's saying, does the system only apply masonry or over fiber cement cladding? I don't think this applies to another cladding, right?
No, so we could, I don't know why you would put a fiber cement sheet cladding up over a cavity and then put this over the top of it. It wouldn't make sense.
Okay.
Unless the only time you would do this system over fiber cement sheet would be if you had a RAB board or a rigid air barrier as the building underlay. Then we would fit our cavity battens on top and then install this over the top of that. Does that answer the question? Does that answer the question?
He said himself, yes, stupid question.
Okay, so I'll go back. So in terms of the question, if this building underlay was fiber cement sheet, we can still do this system over the top of it. I don't care what your building underlay is. If you're in a very high wind zone, you would have rigid air barrier. It wouldn't be just flexible building underlay. All right, but we would just install the system as I've just shown you. All right.
Yeah, and this is a cladding plus outsolation system. So Absolutely. There's no way, or it just doesn't quite make sense to sit on another cladding system.
Yeah, I don't know. Yeah, you just wasted time and cost at the end of the day.
Yeah, cool. Yeah. I think he already heard our answer. So let's move forward.
Okay. Yeah. So now we'll have a quick look at the masonry overlay. Now, the masonry overlay is a pretty popular solution at the moment, and we've completed a couple of projects, in particular up in Waiheke Bay, up in the North Island here in Auckland, north of Auckland, and there's 3 projects there at the moment. There's one just currently underway, and they use this system. So essentially, you can use our blue or gold board, and it's directly adhered onto the concrete block structure. Could be solid concrete structure, And we put a base plaster on the back of the board and fix it on like a giant tile. And then we come through and we use what we call masonry anchors. And these anchor the board just as a mechanical fixing onto the substrate. All right. So that way you get the end result of masonry overlay. All right. So that outsulates the entire structure. And it means that you don't, historically on the inside of a masonry building, you had to strap in line to get insulation or thermal performance. All right. This way you don't have to worry about it. And in fact, I spoke with a client in Christchurch yesterday, and they were doing an outsulation project down there. And because of some of the delays with ability to get plasterboard, they now want us to use our masonry render system to the inside of this building. All right, to give them a plaster finish to the inside.
Yeah.
So this is the outsulation system on a residence in the South Island.
It's beautiful.
Now, the next one, and one of the areas that sort of gets forgotten about, that is thermal performance of the foundations. Now, in the document I mentioned earlier, H1 energy efficiency, the acceptable solution, there's some useful charts in this document to help people, designers, work through what the requirements are. Now, there are two charts that I'm going to be discussing today, and they relate to typical raft foundation situations. There are on slab floor situations, but I'm not going to be touching on those too much. We just want to look at the most common situations. If you want to go and look at the other situations, you can have a look at those online and grab the documentation and work through the tables. So the tables within H1 cover situations where the external walls have a masonry veneer cladding from the walls with other types of cladding, such as our own, the extern, and also masonry veneer walls, the slab on grade floors to other external wall types. As well as this, there are different foundation types that have been allowed for. At present, there are raft and typical slab on grade. Where a concrete floor is only partially in contact with the ground, with other parts being suspended, that part is in contact with the ground and shall be treated as slab on floor. The other parts treated as a suspended floor. So what we want to look at today and show you this one here, and it says floor insulation type none. And then I'm going to show you the tables. So we're going to be highlighting this one here and this one here. So the vertical edge R1 is our Duratherm system. All right. And we're looking at other. So in these charts, any part of the slab on grade that are not part of the thermal envelope, such as a floor and porches, attached garages and storage areas, should be thermally separated by installing vertical edge insulation, such as Duratherm, in between the conditioned and unconditioned parts of the floor. So in this, for the designers that are listening in, you'll need to work out the slab area to perimeter ratio. So that'll be 2.8 for argument in this case. You look at your slab thickness, and there's a variety of slab thicknesses here of external walls onto the slab. So if you determine the slab area, divide the area by the perimeter to get the ratio. So if you've got a 200 mil thick perimeter in terms of the foundation, you'll achieve that you'll require 2.86, and that gives an R value of 1.4. Using the same areas and the ratios from what we just discussed, we now get an R value with our slab edge insulation, the R1 vertical slab edge insulation of now an R value of 1.8. So we've jumped from a 1.4 to a 1.8. So we're going beyond the building codes. Remember the building code was we're looking at R1.6. We're now achieving that. Mm-hmm. All right. So what does that look like? This is slab edge insulation. And this product is what we call Duratherm, and we bring this in from overseas. It comes pre-cut, pre-shaped, and is pre-coated as well. So all that's required for us is we put a a layer of adhesive mortar on the back of this sheet, and we adhere to the outside of the foundation. All right. We have shaped this, and that allows for cavity-based construction. So if you have a cavity up here, it allows for it to breathe still and allow any incidental moisture to get out at the base of the cladding system. All right. I've just mentioned that. So it allows for the insulation, for the drainage of the cavity. Mm-hmm. And it's that high density blue board that we've been talking about, the Extern Blue. And the product itself is 2.2 meters long. So they come in reasonably large lengths and manageable lengths. They're 305 millimeters tall. And this is the chase that I was showing you just before that allows for the rebate to allow for the cavity at this area here. All right. And that was all I had to mention about the foundation. So the solution there is to improve the thermal performance of the foundations. There is product there available for specification to achieve the thermal performance requirements of the proposed or the new H1 changes coming through. So don't forget about insulating your foundations going forward, and we can.
Can we move back to that last slide? I just want to make sure that I get it right. So is this outsulation layer for the foundation, or is that a foundation system?
It's an outsulation layer over the foundation. So this is the foundation that's been built.
Yeah.
And then this board gets adhered onto the outside of the foundation.
Yeah. Okay. Gotcha. So it's basically like if people choose to use the exterior cladding system, which are the two we just mentioned before, plus this foundation outsulation, is basically wrapping the house up from outside to the bottom and stopping maximize the heat loss.
Yep, minimize the thermal loss. Yep.
Yeah.
So what you've got to remember is it doesn't matter what the cladding is up here, you will still need to improve the thermal performance of your floor slabs going forward.
Yeah.
So irrespective if this is brick or weatherboard, you're going to need to still insulate the perimeter of your floor slabs.
Mm-hmm. Yeah. Cool.
All right.
Yeah. So now we have a few questions. One is because this cladding system, the outside is still plaster, and people do have a wrong impression about plaster and link that with leaking. So in what way that you can adjust this impression? And if it's possible, would you mind to explain a bit more why people think plaster cladding house is a leaking house, which I think is 100% right.
Yeah.
Is it tricky? So only at your comfort level.
It's not too tricky. Do you want me to leave that slide up? Because that's the end of the presentation from my side in terms of slides. Do you want me to just leave that in? You can
share the screen so we can have your face back.
Okay. If you can stop it then, and then you'll get me back.
Yeah.
I'll stop that now. There you go.
Yeah, cool. Welcome back.
Well, I can't read. I've got a big box in the middle of my screen, Lillian. I can't read what it's saying to me about building code. I'll just get rid of that. There you go. Cool. Right. In terms of perception in terms of plaster cladding, it's interesting, and it's an historical issue. For over 15 years now, we've been building with new technology in terms of cavity-based cladding systems. Yep. And it doesn't matter what your cladding is now. It needs to be put over a cavity. And the issues weren't just limited to plaster cladding. That was the perception driven by the media that everyone read. One of the challenges we have is the weather tightness issue has a very long tail, and you have a large portion of properties built before the change in the building code that weren't maybe addressed and remedied as they should have been back in the day. And you'll still see news articles, but it needs to be put in perspective that these are older residences, older designs, and we've been using our cavity-based systems for over 15 plus years now, and we just don't have any issue. It's more of an historical issue. And it's interesting. I was talking with a member of the Asian construction fraternity a couple of weeks ago, and I said, "Are you looking at plaster cladding?" And he said, "No." And I said, "Why not?" He said, "We only use it on our expensive houses." So it really it says to me that it's deemed a high performance, expensive product.
Yeah.
Not a leaky product. I think people use it as an excuse from the historical issues, but we just, some of the projects that we deal with, I mean, we're talking in excess of 40,000 square meters of our cladding system are installed every month in New Zealand.
Yeah.
So we're not the outlier. We are becoming more and more the norm. And I think one of the other key drivers is in tough times, a lot of builders want to try and stay on the jobs as long as possible because they don't know when the next job's coming. So they go, I want to do weatherboard so I can stay on the site for longer and I can earn more money. But in very, very busy times, they need other people to help them to achieve the workload. So they do other systems. I know. So they do call some of our trades the fair weather trade. So yeah. So I hope that answers the questions.
Yeah. Is that fair to say if, for example, we have some real estate agents watch our webinar to explain better to their clients? Yeah. Is it fair to say if there's a agent saying, "Oh, this cladding system is only being built in the past 1 to 2 years, and the plaster leaking problem can trace back to 15 or 20 years ago. So if it's a new build and it got all the warranty, then you can assume this is very less likely to have a leaking problem."
Oh, absolutely. If you looked at and I do sympathize with real estate agents because they start selling houses that were built 30, 40, 50 years ago. And they will probably have no debate if they're trying to sell a brick or a weatherboard because the perception is fine. But if the house was built after 2005, it must be on a cavity. I think it was March or April 2005. Excuse me if I've got the months wrong, but so it's important that they understand the timing of when these projects were built, and equally, just because it was built before 2005 doesn't necessarily mean that it's a leaky building. All right. There's a number of factors that would add to it. You know.
Yeah, 100%. It's too complicated to just explain without a specific example because there are so many other factors that can affect it. But anyway, in terms of installation, because you just mentioned some builders want to save some time when it's busy period, then what people can install your cladding system?
Okay, so there's a requirement, and this happened post weather tightness in 2005, and it wasn't just restricted to external cladding, but you've heard of something called LBP. So you're a licensed building practitioner. Now there's a whole raft of LBP categories in New Zealand in the construction sector, and external plaster cladding is a restricted building trade. All right, so we only supply our products to registered LBP plasterers that are licensed to our systems. So it has to be installed by an LBP. All right, it's like you can't go and build your house. Well, if you're building under 30 square meters, you can. But if you're building a house that's bigger than 30 square meters, you must be an LBP. It's the same as if you're a roofer, you have to be an LBP. And any external trade, you must be a registered building practitioner. All right.
Yeah. So in terms of the cost for having people to install the system and the cost of the system, would you say there's any cost competing advantage, like to compare to other existing claddings?
Yeah, I can see a question here from Tony.
That's why I'm asking.
Be cladding and cheaper than fiber cement cladding? So what we're missing here, so you can put fiber cement cladding up, but you're not going to get the thermal performance, and you're not going to get the aesthetics that we can achieve with external plastic cladding. So like for like, I would say, and I don't know how much Tony's paying per square meter, including labor, for his system, but to give you an indication, the Xtherm Blue and Xtherm Gold systems at 50 millimeters thick, and let's just say it's a single story project, you're looking around about $200 a square meter, supplied, installed, finished.
Yeah, $200 per square meter for 50 mils.
And when I say finishing, I mean that's painted, textured, done. All right.
Yeah, cool. He mentioned a brand, but I think it's better to not go in there, just because we need to be fair to all of our clients. Sorry, Tony.
Yeah, that's fine. Yeah, no, absolutely. Yeah.
But if you really want to find out, maybe he can talk to one.
I can see the initials of the company that he was mentioning, and I would, without even mentioning that company, it'd be fair to say that they're challenged in terms of supply. So I think you need to weigh everything up. You know what I mean, in terms of what are the benefits we're going to get, what is the performance. One of the key things with external cladding is I want to deal with one person. I want to deal with one contractor that takes ownership from the building underlay to finish. I don't want to have a discussion with a substrate supplier who then gets involved with someone else to put it on, and then someone else has to come in and finish it. If you can do it with less, I suppose the easiest way to say it is less is more.
Yeah, cool. And he's also asking, what is the lead time to order?
You can ring me tomorrow and I'll drop it out to you.
Okay, cool. Sorry, just another 2 questions before we get this. Do you recommend this new isolation system would be suitable in mid to high density development? And if so, what are the advantages?
Yeah, so we've got a number of cladding systems. We have our Integra lightweight concrete and also the Xtherm systems. Some of the benefits of the Xtherm systems are speed and obviously thermal performance. We get the speed because the cladding's a lightweight system. All right, it's light and easy for the guys to put panels up on walls. Whereas our lightweight concrete system, even though you'll get a better acoustic performance, you won't get the same thermal benefits. So the idea is that if you're doing a medium density development in central Otago, acoustics probably aren't your primary concern.
Yeah,
it's probably thermal performance. But if you're doing a medium density development in the middle of Auckland, acoustics are going to be pretty important. All right. So you can change your system selections based on what you're designing and where you're designing. All right. So that's certainly applicable to medium density construction, and we do multiple projects using these systems. Yeah.
Cool. Yeah, and sorry, another 2 questions. So for the blue and the gold board, like the thing in the middle, the colorful thing, what is the material of them and how heavy they are?
What's the colorful thing in the middle? Do I need to what's the colorful thing?
No, I'm saying the blue foam. Is that foam?
Yes.
Yeah.
Okay.
So all I'm asking is the material of that.
Okay. Do you want me to share my screen again?
No, it's fine. I'm pretty sure people have seen enough of that picture.
Okay. Yeah. Okay. So the blue board is what we call extruded styrene. So commonly EPS or expanded polystyrene that's manufactured here in New Zealand it's made a lot of beads put in a giant big box, and to be really crude, and then heat and steam's applied, those beads expand into a giant cube. That cube gets popped out and then it gets sliced into its thicknesses. Extruded styrene, like a Xtherm Blue, is essentially forced out in one piece. All right. and then it gets cut to the required length.
Mm-hmm.
The Xtherm Gold is extruded, but it's extruded into big, thick panels, and then that gets sliced. All right. So, but it needs, the Xtherm Gold needs to be cut with a saw, a band saw, whereas the polystyrene can be cut with a hot wire. Xtherm Gold does not melt and does not cut with a hot wire. We have to use a saw because it's so hard, and it's got better fire retardant properties than traditional polystyrene.
Yeah, cool. Sorry, and how heavy are they? Are they heavy? Are they not heavy?
They're lightweight. To be fair, I think you're looking around about 6 kilos per sheet. It's about 1.4 square meters of wall area is essentially,
6 kilo.
That's not
heavy.
So remember at the beginning I talked about the best insulator is air?
Yeah.
These products are generally between 95 and 98% air.
Yeah.
All right.
Yeah. And okay, last question for you, Tony. He's asking if it's a bit too costly for average terrace house, and he has never seen one being used for those kind of projects before. And do you have any examples?
I don't know why this photo didn't come up before when I put it into the file.
Yeah,
we do. Yeah, absolutely. Have plenty of projects, numerous projects. I'll download this and
just while you're downloading, I also wanna ask you, what is the range of the texture and the finishes available for the system? Yeah.
So we've got a massive range of textures. We have sample boxes of all the different full texture ranges, and you can contact us and we'll send you a sample box of those textures, so you can actually then select your finishes. Normally, they're traditional sponge applied, float applied finishes, but it's they're generally there's a very, very wide range, and obviously the color selections are full range Resene colors. I'll share this one.
Okay. Yep. Just for you, Tony.
Just for you, Tony. Tony's getting a prize for the most questions today. So, Tony, this was the medium density Nelson. This is just one project. This was in Master Build House of the Year, multi-unit development. This is a project with over 260 units in it, so it's not small. Yeah, so this is not small. And there's also another project up that way, I think in Motueka, and it's Olive Grove, and that's a similar sort of project. They have no shortage. Christchurch, we do stack loads, and up here in Auckland, we're doing a lot of medium density with our central barrier into tenancy walling systems. But once again, it's probably down to those selections that clients want for external cladding. Particularly in the Auckland market. So, yeah.
So we'll probably see more in the future with the change of the H1 building code.
Absolutely.
Yeah.
And for Tony, is Tony based in Auckland?
Yeah, he is.
All right. So, Tony, I mean, if you're driving on the northern northwestern motorway, it's Squadron Drive off ramp to Hobsonville. Sorry for everyone else. You don't know Auckland, but if you see the Somerset project. On the right-hand side, Somerset Retirement Village on the right-hand side. It's all external plaster, outsulation systems. Yeah, the first work we did there started 6 years ago. The very first villas, when you get to the roundabout off Squadron Drive, you'll see the original outsulation systems we did there. And we're still working on that site. In fact, we're on the final stage, so it's been going for a while. So, yeah. All right, I'll stop sharing now.
Okay, cool. Anyway, enough question and enough talk. I think we probably have learned a lot. I'm just gonna wrap it up in Chinese. Time for you to listen and learn. 所以其实今天在我们的公开课内容中，我觉得这个也算是一种新科技的分享，或者说是一个新的知识的普及吧。除了关于 H1 这个 energy efficiency 在这个 建筑规范的这个升级，以及对外墙系统上会有什么样的要求，就是这部分的知识之外呢，其实我们还学到了，我至少在接触 Resene Construction 的这个外墙系统之前，我是不知道外墙也可以具有保温功能的。所以随着未来的这个 Building Code 的要求，尤其在能源效率这个方面啊，要求越来越高，我相信这个产品被投入使用以及在 BC 中被批到的可能性也会越来越大。所以今天这样也是一个非常好的机会，大家能够通过这样的一个 presentation 去了解外墙的保温、隔热以及防潮的作用，希望对您的家或者是对您未来的项目有了非常大的帮助。这个还有一个事情要跟大家讲一下，下个周因为是这个复活节的假期，所以我们下周4的直播会暂停一期，我们会再在下一个周4月21号的时候继续在直播间跟大家不见不散。好了，直播的最后呢，记得大家记得一定要扫码进群去回答今天的问题。我们本期的问题是我们的这个Xtherm Gold 100 ml 的厚度的时候，它的 R 值是多少知道答案的您不妨扫码到我们的微信群里面来进行抢答，问题会在直播结束后在群内统一提问，以及不要忘记点击屏幕右上角的关注主播，期待您继续关注我们未来的建筑会公开课。Okay, Mike, that was a lot for you, and I'm pretty sure our audience have learned a lot. Thank you very much for sharing today. It's really easy and cheerful. And have you picked up more Chinese words?
No.
It's okay. Free Chinese lesson.
I'll work on it. I promise you. I'll work on it.
Okay, very good.
Thank you very much, everyone. Thank you very much for everyone tuning up.
Okay, cool. Thank you. 谢谢大家，拜拜。我们下期见啊，拜拜。